This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 5, Lesson 10, The Waterside Capstone. No new formulas. You already own cooling towers, combustion and boilers, heat exchangers by LMTD and by effectiveness NTU, chillers and condensers, heat pumps, coils, and the pump and compressor as machines. This lesson is the method under exam pressure. Name the equipment, route it to its chapter's equation, and solve. We'll work 4 problems: a cooling tower, a heat exchanger, a pump, and a boiler. The decision map. Week 5 spreads across 6 chapters, so name the equipment first. That alone picks the chapter and the equation. A cooling tower, heat rejection from mass flow times specific heat times range, then tons over 15,000. A heat exchanger with an outlet temperature unknown, effectiveness NTU, both terminal temperatures known, LMTD. A pump sped up, the affinity laws, then an NPSH margin check. A boiler, useful heat over the fuel's heating value. Identify the equipment, reach for the equation, solve. Problem 1. A cooling tower on a condenser-water loop. Build the heat rejection from the water rate. Mass flow is 1,000 GPM times 8.34 times 60, about 500,000 pounds per hour, times specific heat times the 12-degree range gives about 6 million BTU per hour. Divide by the tower ton, 15,400 tons. Divide by the refrigeration ton, 12,000, and you'd get 500. That's the signature trap. Evaporation makeup is the flow times range over the latent heat. Problem 2. A heat exchanger where an outlet temperature is unknown, which is exactly when you reach for effectiveness NTU instead of LMTD, because LMTD would force you to iterate. The cold stream is the minimum capacity rate, so the ratio is 1/2, and NTU is 1.5. The counterflow effectiveness relation gives about 0.69. Heat rate is effectiveness times the minimum capacity rate times the inlet difference, about 967,000 BTU per hour. Back that out to the outlets. Cold leaves near 157, hot leaves near 152. Problem 3. A pump sped up from 1750 to 2100 RPM, a ratio of 1.2. Flow scales with the ratio to 600 GPM, head with the square to 144 feet, and brake horsepower with the cube to about 26. Now the suction margin. Net positive suction head available is atmospheric head plus the static term minus vapor pressure head minus friction, about 21 feet. Required is 16, so the margin is positive and there's no cavitation. But available must exceed required, and speeding the pump up raises the required value, so recheck at the new point. Problem 4. A natural gas boiler. Combustion efficiency is the useful heat delivered to the water over the heating value of the fuel burned. On the higher heating value basis, the fuel supplies 10 million BTU per hour, so efficiency is 80%. On the lower heating value basis, the same fuel counts as 9 million, so efficiency is 89%. Same boiler, same output, only the denominator moved. Higher heating value includes the latent heat of vaporization, lower excludes it. Always report which basis you used. The week's traps in one screen. On tons and exponents, the cooling tower ton is 15,000 BTU per hour, and the refrigeration ton is 12,000. Cross them, and 400 tons becomes 500. And the affinity laws go flow, head, power as the first, second, and third power, with specific weight touching only brake horsepower. On method, an unknown outlet means effectiveness NTU. Both terminal temperatures known means LMTD. On signs and basis, net positive suction head available must exceed required, and suction lift makes the static term negative. Combustion efficiency needs its basis stated. And to go from EER to COP, you divide by 3.412. 12 becomes 3.5. Look up discipline. This is the cross-chapter week, so the trap is hunting Chapter 9 for everything. Pumps live in Chapter 3, cycles and compressors in Chapter 4, heat exchangers in Chapter 5, water-cooled condensers in Chapter 8, and combustion in Chapter 10. Only the cooling tower is native to Chapter 9.3. Know which chapter owns the equipment, jump to it, Read the row and confirm. Never search from scratch under the clock. The method and the clock. Before you compute, name the equipment. A tower, a heat exchanger, a pump, or a boiler or chiller, because that alone picks your chapter and your formula set. For a tower, heat rate, then tons over 15,000, and makeup from flow, range, and latent heat. For a heat exchanger, an unknown outlet means effectiveness NTU, both terminals known means LMTD. For a pump, scale by the affinity laws, then check that suction head available beats required. For combustion or a chiller, useful overheating value, or EER, divided by 3.412. Keep the units the formulas expect, and if a property isn't printed, the problem gives you the number. That's a wrap on Week 5, the water side and central plant. 10 lessons: hydronic piping and the operating point, cooling towers, combustion and boilers, heat exchangers by LMTD and by effectiveness NTU, chillers and condensers, heat pumps, coils, the pump and compressor as machines, and this capstone tying them together under time. More HVAC weeks are on the way. Subscribe so the next one reaches you. Everything's at PEPrepEngine.com. A cheat sheet, worked solutions, and a short quiz are attached here. If the course helped, please subscribe, and good luck on exam day.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.